There is a question that has been sitting at the edge of serious science for decades, a question that most academics treat with caution precisely because it is so large, so uncomfortable, and so difficult to definitively answer either way. What if the world we inhabit is not the first version of itself? What if the civilization we are building, with its cities and its technology and its accumulated knowledge, is not humanity's first attempt at this project? What if the landscape of archaeological puzzles, the myths that appear in every culture, the geological anomalies, the sites that do not fit the timeline, and the gaps in the human story are not random mysteries but are pieces of a pattern, evidence of something that happened before the world we know? This is not a video about conspiracy theories. It is not a video about ancient aliens or suppressed histories or secret government cover-ups. It is a video about something more interesting and more substantiated than any of those things. It is a video about what the genuine scientific evidence actually shows, what the legitimate scientific debates actually involve, and what a serious, honest reading of the archaeological and geological record suggests about the world that existed before the one we know. The evidence we will examine is real. The debates we will explore are real. The mysteries we will encounter are genuinely unresolved by mainstream science. And the honest conclusion that emerges from examining them carefully is more surprising and more thought-provoking than either the dismissive explanation of the mainstream or the overclaimed narrative of the alternative history community. Let us begin not with a mystery, but with a fact. A geographic fact that most people have never fully absorbed. The world we're standing on is not the world that existed 12,000 years ago, and the difference is not subtle. Since the last glacial maximum, approximately 21,000 years ago, global sea levels have risen by approximately 120 meters. 120 meters. That is about 40 stories. Every coastline on Earth has moved. Every continental shelf that was above water during the last ice age is now submerged, and the total area of previously habitable land that is now underwater is approximately 27 million square kilometres. 27 million square kilometres. For comparison, North America is approximately 24 million square kilometres. We have lost an area larger than North America to the rising seas since the last ice age, and this lost land was not empty. It was the most productive and the most heavily populated land available to Pleistocene humans. Coastal environments, river deltas, continental shelves, the fertile plains that the rivers of the Ice Age built at the margins of the continents. These were exactly the kinds of environments that human populations preferred and congregated in. The archaeological record of the Pleistocene world is therefore almost by definition incomplete. The sites where the most sophisticated and the most populous human communities lived are for the most part underwater. What we can excavate on land is the interior, the highlands, the places that were not the centres of late Pleistocene human life but the periphery. The caves of Europe are not the heart of Pleistocene civilization, they are its mountains and margins. This is not speculation, it is physical geography. And it means that when we look at the Pleistocene world and try to assess what was there, we're doing something like trying to understand modern civilization by looking only at Tibetan monasteries, while the rest of the world's infrastructure lies underwater. Whatever was happening in the richest and most populated coastal environments of the Pleistocene world is, for the most part, inaccessible to us. This single fact should make us humble about our certainty that we know what the world was like before the flooding. We do not know. We know some of what was in the highlands and the interiors. We do not know what was on the coastlines, and the coastlines were where the people were. With that foundation established, let us look at the most extraordinary thing that has happened to archaeology in the past 30 years. In 1994, a German archaeologist named Klaus Schmidt was doing a survey of the hill of Göbekli Tepe in southeastern Turkey, working from information about a strange collection of stones that had been noted by a previous American survey team in the 1960s and identified as medieval graves. Schmidt looked at the stones more carefully and realized they were not medieval graves. They were something entirely different, something whose existence, according to everything archaeologists believed about the development of human civilization, was simply not possible. What Schmidt and his team eventually excavated over the following decades was a large complex of circular stone enclosures, each containing multiple massive T-shaped limestone pillars arranged in precise geometric patterns. The pillars are carved with elaborate bas-relief images of animals: foxes, boars, snakes, birds, scorpions, spiders, and various other creatures, rendered with artistic skill and obvious intentionality. Some of the pillars have carved human arms on their sides, suggesting an anthropomorphic element. The largest pillars are approximately 6 meters tall and weigh up to 20 tons. The site has been dated using multiple methods, including radiocarbon dating of organic material from the fill deposits. The oldest layers of Göbekli Tepe date to approximately 11,600 years ago, or roughly 9600 BC, 11,600 years old. And this is where the problem begins for the standard narrative of human development. The standard narrative says that complex organized societies capable of building monumental architecture came after agriculture. The sequence was supposed to be: hunter-gatherers develop agriculture. Agriculture leads to settled communities. Settled communities accumulate surplus. Surplus enables specialization of labor. Specialization of labor eventually produces the organizational capacity to build large monuments. Göbekli Tepe was supposed to come at the end of this sequence, not the beginning, but the radiocarbon dates are unambiguous. Göbekli Tepe was built by people who, at the time of construction, had not yet developed agriculture. The domesticated plants and animals that would characterize the Neolithic period were not yet present in the region. These were pre-agricultural people, building what appears to be the world's oldest known monumental complex. This reversed the causal relationship that archaeologists had assumed. Instead of agriculture producing the organizational surplus that made monuments possible, it now appears that the organizational impulse, the need for large communal gathering places and the social structures capable of building them, preceded agriculture. Some researchers have proposed that Göbekli Tepe itself may have been one of the drivers of agriculture, that the need to feed the large gatherings of people who came to build and use the site may have incentivized the cultivation of wild grasses in the surrounding area. But here is what makes Göbekli Tepe even more interesting in the context of our question. The builders did not abandon it. They buried it. Approximately 8,000 years ago, after perhaps 3,000 years of active use, the entire complex was deliberately filled in with rubble, animal bones, and stone tools, preserving the structures beneath the fill, every enclosure, every pillar, buried by the people who had built and used them. Why? We do not know. The specific motivation for the deliberate burial of Göbekli Tepe is one of the genuinely unanswered questions of archaeology. Proposals include a ritual ending of the site's sacred function, a response to a change in religious practice, or a deliberate act of preservation by a culture that understood it was in transition and wanted to protect what it had built from being destroyed by what was coming after it. That last interpretation is speculative, but it is not unreasonable. The deliberate burial of Göbekli Tepe suggests people making a considered decision about preserving something important, and the thing they preserved has survived, intact, for 8,000 years beneath the soil of a Turkish hillside, waiting to be found and to overturn our understanding of what the world once was. Göbekli Tepe is not alone. Since its discovery, the application of new dating technologies and the excavation of sites that had previously been assumed to be more recent has revealed a pattern. The world of 12,000 years ago was more sophisticated, more organized, and more capable of complex cultural production than the standard narrative had assumed. Not everywhere, not universally, but in more places and at an earlier date than the previous model predicted. What this tells us is not that there was a lost advanced civilization with technology comparable to our own. What it tells us is that the specific cognitive and social capabilities required to build complex organized structures, to maintain large communal projects, to produce sophisticated symbolic art, were present in human populations before we thought they were. The raw material for civilization was there earlier than we realized, and the question of what happened to it, why the specific cultural traditions that produced Göbekli Tepe did not develop continuously into the urban civilizations of the Fertile Crescent, but instead seemed to have been interrupted and rebuilt, is a genuinely interesting one. To understand the interruption, we need to return to the Younger Dryas. We explored this event in our video about the seventh civilization, but in the context of the rebuilt world question, it deserves deeper examination. The Younger Dryas began approximately 12,900 years ago, during a period when Earth was warming out of the last ice age and the world's ecosystems were reorganizing toward their current configurations. The warming had been underway for several thousand years. Human populations were growing, cultural complexity was increasing, and then, within the span of what the ice core record shows as decades, the warming stopped and reversed. Global temperatures plunged. Ice sheets that had been retreating began to re-advance. The productive environments that had been supporting growing populations were devastated. The Younger Dryas cold period lasted approximately 1,200 years, from 12,900 to 11,700 years ago. When it ended as abruptly as it began. The Greenland ice cores record the transition from Younger Dryas cold to Holocene warmth in approximately 50 years, possibly less. This is one of the most rapid natural climate transitions in the geological record. The cause of the Younger Dryas has been debated for decades. The traditional explanation is the drainage of glacial Lake Agassiz, the enormous freshwater lake that had accumulated behind the retreating North American ice sheet into the North Atlantic, disrupting the thermohaline circulation and triggering the abrupt cooling. This mechanism is plausible and probably contributed, but in 2007 something more dramatic was proposed. A team of 26 researchers led by Richard Firestone of the Lawrence Berkeley National Laboratory published a paper in the Proceedings of the National Academy of Sciences proposing what has come to be known as the Younger Dryas impact hypothesis. The hypothesis proposes that one or more cometary or asteroidal fragments, possibly the remnants of a fragmenting comet, impacted or exploded over the Laurentide ice sheet of North America approximately 12,900 years ago, triggering the Younger Dryas cooling through a combination of direct effects, massive wildfires, and disruption of the ice sheets and ocean circulation. The evidence for this hypothesis has been accumulating. At dozens of sites across multiple continents, researchers have found a specific layer in the sediment record that dates to approximately 12,900 years ago, called the Younger Dryas Boundary or YDB layer. This layer contains a suite of anomalous materials that are not normally found in the geological record, but that are characteristic of extraterrestrial impact events. These include elevated concentrations of platinum and iridium, which are rare on Earth but common in meteoritic material. They include nanodiamonds, microscopic diamond particles that form only under the extreme pressures of impact. They include cosmic spherules, tiny glass beads formed from the fusion of terrestrial and extraterrestrial material during an impact. They include a carbon-rich black mat that records a major biomass burning event, an enormous wildfire. This same layer has been found at sites in North America, Europe, the Middle East, and Africa. A 2018 study published in the Journal of Geology examined the YDB layer at 23 sites across 3 continents and confirmed the presence of the impact markers. A 2023 study confirmed the platinum anomaly at sites in South Africa. The evidence is not found everywhere, and there are sites where it has not been confirmed, which has led to criticism of the hypothesis. But the number of confirming sites across a wide geographic range makes it increasingly difficult to dismiss. If the Younger Dryas impact hypothesis is correct, what it describes is one of the most significant natural catastrophes in human history. A cosmic impact or airburst over the North American ice sheet, producing enormous wildfires across the northern hemisphere, destabilizing the ice sheets and triggering the freshwater pulse into the North Atlantic that shut down the ocean circulation, plunging the world into 1,200 years of cold that devastated the ecosystems and the human populations that depended on them. In the context of the rebuilt world question, the Younger Dryas impact hypothesis is significant for 2 reasons. First, if it is correct, it provides a specific mechanism by which the relatively sophisticated late Paleolithic cultures of the period were catastrophically disrupted. The world of 12,900 years ago was not a primitive world. It was the world that produced Göbekli Tepe. It was the world of the cave painters whose work at Chauvet we still regard as masterpieces. It was the world of the Natufian culture in the Levant that was in the process of developing something very close to agriculture and permanent settlement. All of this was disrupted by a catastrophe that the hypothesis identifies as a cosmic impact. Second, and more speculatively, the YDB layer itself is physical evidence in the geological record for a specific catastrophic event at a specific time. If human populations living at that time experienced this event, it would have been the most catastrophic event in the memory of anyone alive. It would have been, from the perspective of the survivors, the end of the world. And the specific time of the Younger Dryas boundary, approximately 12,900 years ago, is within the range of dates that appear in the flood myths and Golden Age traditions of cultures across the world. Before we go further, take a moment to get comfortable. Subscribe and leave a like if this is worth your time, and drop a comment telling me where in the world you are. I always read them. Let us continue. The flood myths of the world are one of the most discussed and most debated topics in comparative mythology. Virtually every major human culture, on every inhabited continent and every large island group, has a tradition describing a catastrophic flood that destroyed a previous world and left only a small group of survivors from whom the current humanity descends. the specific details vary enormously. The name of the survivor varies, the reason for the flood varies, the theological framework in which the story is embedded varies, but the structural core is consistent across cultures that had no contact with each other, a world before, a catastrophe of water, a survivor, a new beginning. We have discussed flood myths in previous videos on this channel, but in the context of the rebuilt world question, there is a specific aspect of the flood myth tradition that deserves attention: the timing. Plato wrote about Atlantis in two dialogues from approximately 360 BC, the Timaeus and the Critias. He presented the story as received tradition from Egyptian priests, transmitted through several generations of intermediaries before reaching him. The key number in Plato's account is the date he gives for Atlantis's destruction, 9,000 years before the time of the Egyptian priests who told the story to Solon, who was Plato's ancestor and source. If we take the Egyptian context as approximately 600 BC, when Solon visited Egypt, and add 9,000 years, we get approximately 9,600 years BC. In the dating system used by archaeologists, this is approximately 11,600 years ago. 11,600 years ago. The date of the construction of Göbekli Tepe, the date of the end of the Younger Dryas, the date of the most catastrophic climate transition of the current interglacial. The correspondence may be coincidence. Plato's numbers may be mythological rather than historical. The Egyptian priests may have been preserving genuine historical memory, or may have been elaborating a theological narrative. We cannot know for certain, but the specific date Plato's story points to corresponds precisely to the period that the geological and archaeological record identifies as one of the most dramatic disruptions in the history of human civilization. The Sumerian King List is another document that encodes a possible memory of a world before and a world after a catastrophe. We discussed this in the 7th civilization video. The list records kings who ruled before the Great Flood with reigns of tens of thousands of years, followed by a dramatic reduction in the length of reigns after the flood. The specific numbers are clearly mythological, but the underlying structure, an acknowledgement that a world existed before the flood that was qualitatively different from the world after, appears in multiple independent traditions from the Near East. What does this mean? It means that multiple ancient cultures, across multiple independent traditions, preserved a memory of a world before a great catastrophe that ended it. The theological and mythological elaboration varies by culture. The core memory appears to be consistent, and the geological record provides us with a real catastrophe, or series of catastrophes, that occurred at approximately the time these traditions point to. The rebuilt world hypothesis in its most defensible form is not that there was a technologically advanced civilization whose cities has been lost. It is that the world of the late Pleistocene was culturally and organizationally more sophisticated than we previously believed, that it was catastrophically disrupted by a combination of events associated with the end of the last ice age, including the Younger Dryas, and that what came after, the Neolithic Revolution and the rise of the first cities, was in significant part a rebuilding process, a reconstruction of organizational complexity from a reduced baseline by survivors who retained cultural memories of what had existed before. This version of the story is consistent with the archaeological record, with the geological record, with the genetic record, and with the mythological record. It does not require the existence of lost continents or suppressed technologies. It requires only that the world of 12,000 years ago was different from, and in some respects more sophisticated than, we previously assumed. And this is increasingly what the evidence is showing us. Let us examine some specific archaeological puzzles that are genuinely unexplained by the current mainstream model, and be honest about what they do and do not suggest. The Antikythera mechanism is perhaps the most concrete and undeniable example of ancient technological sophistication that exceeds what the mainstream model predicts. It was discovered in 1901 in a shipwreck off the Greek island of Antikythera, recovered from approximately 45 meters of water alongside bronze and marble statues and other objects from the 1st century BC. Initially, the encrusted and fragmented mechanism attracted little attention. It was not until the 1950s, when a British science historian named Derek de Solla Price began a detailed analysis, that the extraordinary nature of the device began to be understood. The Antikythera mechanism is an ancient analog computer. It contains at least 30 bronze gears of extraordinary precision, meshing in complex arrangements to model the movements of the sun and moon, track the metonic cycle used by Greek astronomers to predict eclipses, and calculate the positions of the 5 planets known to the ancient Greeks. It was used to predict eclipses and to track multiple astronomical cycles simultaneously. The device is typically dated to approximately 150 to 100 years BC, based on the astronomical events it is calibrated to, though some researchers argue for a date as early as 205 BC. Nothing comparable in mechanical sophistication was produced by any known civilization until the 14th century AD. More than 1,000 years later. The gear trains and epicyclic mechanisms in the Antikythera mechanism were not matched by any documented technology until European clockmakers of the late medieval period. The gap between the Antikythera mechanism and the next comparable device is approximately 1,400 years. What does the Antikythera mechanism tell us? It tells us that the specific human capacity for complex mechanical problem solving existed in the ancient world at a level that produced extraordinary results that were not recognized as possible by modern scholars until the mechanism was subjected to modern analysis. It tells us that the loss of specific technical traditions is real, and that sophisticated capabilities can be developed, lost, and forgotten within the span of centuries. It does not tell us that there was an advanced civilization predating ancient Greece. The mechanism is clearly a product of the Greek astronomical and mechanical tradition, but it does tell us that human technical sophistication can be dramatically underestimated by later generations, and that the archaeological record can preserve extraordinary examples of capabilities that we had not attributed to their era. The question this raises for the rebuilt world hypothesis is, what other extraordinary capabilities existed in the ancient world that we have not yet recognized or recovered? What was lost in the Bronze Age collapse that we have not yet found or understood? What was built by the cultures of the late Pleistocene whose coastal sites are underwater? The Antikythera mechanism survived because it fell into the cold, oxygen-poor waters of the Aegean and was preserved in a shipwreck. The things that sank off the coasts of Pleistocene continents have been in warmer, more oxygenating, shallower waters for 12,000 years. Most of them are gone. We cannot know what was lost. There is a scientific debate that has been going on since 1990 that bears directly on the question of how old, organized, sophisticated human activity really is. It is a debate about geology and specifically about the weathering patterns visible on one of the most famous monuments in the world. The Great Sphinx of Giza stands on the Giza Plateau near Cairo, Egypt. It is one of the most studied monuments in the world. It is conventionally dated to approximately 4,500 years ago, to the reign of Pharaoh Khafre during the Old Kingdom of Egypt. This dating is based primarily on circumstantial historical evidence and the proximity of the Sphinx to the pyramid complex of Khafre. In 1990, a geologist named Robert Schoch of Boston University, working with alternative history researcher John Anthony West, examined the weathering patterns on the Great Sphinx and its enclosure very carefully. Schoch's specific expertise is in the geological analysis of ancient structures, and what he found on the Sphinx enclosure walls was unexpected. The weathering on the body of the Sphinx, and particularly on the walls of the enclosure in which it sits, shows a pattern that, in Schoch's analysis, is characteristic of weathering by precipitation rather than by wind and sand. The deep undulating vertical fissures in the limestone of the enclosure walls, in Schoch's assessment, are the result of water erosion from heavy rainfall over extended periods, not the horizontal fluting that typically characterizes wind and sand erosion in desert environments. The geological significance of this observation is that the region around Giza has not received the kind of heavy rainfall that would be required to produce significant water erosion for thousands of years. The last period during which the region received significant precipitation was the African humid period, sometimes called the Green Sahara, which lasted from approximately 9,000 to 5,000 years BC. For the weathering on the Sphinx to be the result of precipitation, the body of the Sphinx would need to have been carved and exposed to rainfall during this period, implying a date of construction of at least 7,000 to 9,000 years ago, possibly significantly older. This hypothesis has been hotly contested. Most Egyptologists reject it, arguing that the dating of the Sphinx to Khafre's reign is well established from historical and archaeological evidence, and that the weathering could be explained by other mechanisms including subsurface water movement and ancient dew condensation rather than direct rainfall. Geologists have been more divided, with some supporting Schoch's analysis and others offering alternative explanations for the weathering patterns. The debate remains genuinely unresolved. This is important to state clearly. The Sphinx water erosion debate is not a fringe claim that mainstream science has definitively disproved. It is a legitimate scientific controversy involving professional geologists and archaeologists who disagree about how to interpret the physical evidence. The current status of the debate is that Schoch's position has not been confirmed by the broader geological community, but it has also not been definitively refuted. If Schoch is correct, the implications are significant. The Sphinx would be among the oldest known monumental human constructions in the world, predating Göbekli Tepe in its current form while being in some ways more architecturally ambitious. The civilization that produced it would have existed in what was then a green and productive North Africa, before the desiccation of the Sahara that followed the end of the African humid period. This is speculative. The standard dating may be correct. But the specific anomaly that Schoch identified, the precipitation weathering patterns on a structure in a region that has been arid for most of recorded history, is a real geological observation that deserves honest examination. Let us now look at the question of ancient astronomical knowledge, because it provides some of the most interesting specific evidence for sophisticated intellectual activity in the ancient world that our standard timelines have difficulty explaining. Astronomy requires patience, precision, record keeping, and the transmission of knowledge across multiple generations. A single person cannot develop a comprehensive model of celestial mechanics. It requires the accumulated observations of many observers over many generations, carefully recorded and transmitted. The sophistication of ancient astronomical knowledge therefore tells us something about the depth and continuity of the cultural traditions that produced it. The Great Pyramid of Giza provides a specific example. The precision of the Great Pyramid's orientation has been measured and confirmed repeatedly. The four sides of the pyramid are aligned to the cardinal points, with an accuracy of approximately 1/20th of a degree. The base is level to within 2 centimeters across a length of 230 meters. The slope of the sides and the relationship between the base perimeter and the height encode the mathematical constant pi with reasonable accuracy. These are not accidental achievements. They require sophisticated surveying methods, precise astronomical observations to determine cardinal directions, and mathematical understanding. The specific method used to achieve these results has been debated, but the results themselves are documented. The shafts of the Great Pyramid provide another astronomical anomaly. 2 shafts in the King's Chamber are angled at approximately 32 and 45 degrees relative to the horizontal. Astronomical analysis has shown that these shafts were aligned to specific stars as they appeared approximately 4,500 years ago. Specifically, one shaft aligned to Orion's belt, specifically the star Alnitak, and the other to the star Thuban, which was the pole star at the time of the pyramid's construction, due to the precession of the equinoxes. The precession of the equinoxes is a slow wobble of Earth's rotational axis that takes approximately 26,000 years to complete one full cycle. Knowledge of the precession requires astronomical observations spanning at least several centuries, ideally much longer, to detect the slow drift of the pole star through the background of stars. The fact that the shaft alignments of the Great Pyramid appear to encode the position of the pole star at the time of construction suggests that whoever designed the pyramid had knowledge of precession. How they obtained that knowledge, whether through long-term systematic observation by the Egyptian astronomical tradition alone, or whether they were drawing on an older and longer tradition of astronomical observation, is not answered by the fact of the alignment itself. But the knowledge is there, encoded in the structure. Nabta Playa in what is now the Egyptian Sahara provides an even older example. A dry lake bed in the southern Egyptian desert, Nabta Playa was occupied seasonally by nomadic cattle herders approximately 9,000 to 6,000 years ago during the African humid period. At Nabta Playa, archaeologists have found a megalithic stone circle and other stone alignments that appear to have been built with astronomical orientations, including alignments to the summer solstice sunrise and to specific bright stars as they appeared at that time. Nabta Playa predates Stonehenge by several thousand years. If the astronomical alignments are intentional, and the research suggests they are, then the practice of building astronomically aligned stone monuments was occurring in North Africa millennia before we typically assume it began. The broader picture that emerges from examining ancient astronomical knowledge is one of deep continuity. The specific astronomical knowledge encoded in monuments and traditions across the ancient world suggests that systematic astronomical observation, careful record keeping, and the mathematical modelling of celestial cycles were being conducted over very long time periods, in some cases potentially stretching back before the conventional beginning of civilization. This does not require a lost advanced civilization. It requires only that we take seriously the possibility that specific intellectual traditions, maintained and transmitted through oral culture and through the specific training of specialist astronomical observers, could persist and accumulate over millennia even without writing. Let us now be specific about what the rebuilt world hypothesis does and does not claim, because this is an area where honesty about the limits of the evidence is as important as enthusiasm about its implications. What the evidence does support is the following. Human cognitive and organizational sophistication was present before the conventional timeline suggests, as demonstrated by Göbekli Tepe and by the increasingly well-documented evidence of late Pleistocene symbolic behavior. The world of 12 to 15,000 years ago was disrupted by a combination of rapid climate change, possible cosmic impact, megafaunal extinction, and sea level rise that eliminated the most populated coastal habitats and forced the survivors to rebuild from a reduced baseline. Sophisticated cultural and intellectual traditions, including astronomical knowledge and the capacity for large-scale social organization, appear in the early archaeological record in forms that suggest they developed from even earlier, now inaccessible antecedents. Multiple independent cultural traditions preserve memories of a world before a catastrophic flood that are structurally similar enough to suggest a common experiential root. The geological record contains physical evidence of a major catastrophic event at the Younger Dryas boundary, approximately 12,900 years ago, that may represent the specific catastrophe that these traditions remember. What the evidence does not support is the following. There was no advanced civilization with technology equivalent to or exceeding modern technology existing before 12,000 years ago. There are no hidden cities, no suppressed archaeological discoveries of pre-Columbian skyscrapers or ancient power plants. The specific claims of the more extreme alternative history tradition, alien construction of pyramids, ancient nuclear weapons, pre-Ice Age global civilizations with flight or electricity, are not supported by the evidence and in many cases directly contradict it. The rebuilt world hypothesis in its defensible form is more modest and more interesting than the extreme versions. It says that humanity's cultural and organizational development was longer and more complex than the standard narrative acknowledges, that it was catastrophically disrupted at the end of the Pleistocene, and that the civilizations of the Neolithic and Bronze Age were in significant part reconstructions rather than original developments. This hypothesis is consistent with the evidence. The extreme version is not. Let us stay with the second call to action for a moment. Subscribe if you have not already. Leave a like and a comment telling me where you are. I always read them. Now let us continue into the most specific and testable aspects of the rebuilt world question. The genetic record of modern humanity provides some of the most direct evidence for catastrophic events in the human past, and for the specific survival dynamics that the rebuilt world hypothesis predicts. We have discussed the Toba bottleneck in the 7th civilization video. The genetic evidence for a severe population reduction approximately 74,000 years ago, corresponding to the Toba supervolcano eruption, is one of the most robust findings in human genetics. All modern humans show levels of genetic diversity substantially lower than those of other great apes, despite being far more geographically widespread. This low diversity reflects a period when the human population was reduced to a small, founding group from which all modern humans descend. The Toba bottleneck is the first genetic scar. but it is not the only one. More recent genetic analysis has revealed additional signals of population stress and reduction in various lineages at various times. The specific signal of the Younger Dryas period is more difficult to detect in modern genetic data because it occurred more recently and because subsequent population growth has partially obscured the signal. But archaeogenomic studies examining ancient DNA from this period have found evidence of significant population disruptions, site abandonments, and demographic reorganizations consistent with the scale of the Younger Dryas catastrophe as described by the impact hypothesis. More interesting for the rebuilt world question is the discovery, through ancient DNA analysis, of the previously unknown human lineages that modern people carry in their genomes. Denisovans, an archaic human lineage known only from a handful of fragmentary fossils from Siberia, contributed genes to the ancestors of modern people outside Africa, particularly to Melanesians and Aboriginal Australians, who carry substantial percentages of Denisovan ancestry. Neanderthals contributed genes to virtually all modern non-African humans. The genetic evidence suggests multiple instances of contact and interbreeding between modern humans and other archaic human lineages, some of which are otherwise archaeologically invisible. What this tells us is that the history of human population movement, interaction, and cultural exchange is more complex and more ancient than the standard narrative has assumed. The specific populations that survived the various bottlenecks and catastrophes that punctuate human prehistory were not culturally blank. They carried with them the accumulated knowledge of the lineages from which they descended, knowledge that included in some cases technologies and traditions of extraordinary antiquity. The specific genetic finding that is most relevant to the rebuilt world hypothesis is the evidence for what population geneticists call founder effects at various points in the Holocene. Multiple studies of the genetic diversity of populations across different continents have found patterns consistent with rapid population expansion from small founding groups at dates corresponding to the major transitions of the early Holocene, the period of rebuilding after the Younger Dryas. The picture that emerges from the genetic record is one of dramatic bottlenecks followed by rapid expansions. Precisely the demographic signature we would expect from a catastrophe followed by a rebuilding process. The survivors of each bottleneck carried the cultural memory of what had existed before the catastrophe and used it as the foundation for what they built afterward. Let us look at specific sites that have recently been pushing back the boundaries of what we know about organized human activity in the early Holocene. Karahan Tepe is a site in southeastern Turkey, discovered in 1997 and being excavated since 2019. Like Göbekli Tepe, it contains T-shaped pillars arranged in circular enclosures. The site appears to be contemporaneous with, or possibly even older than Göbekli Tepe. Excavations at Karahan Tepe have revealed additional carved imagery, including phallic symbols and figures that appear to represent human beings in a more developed form than the anthropomorphic elements at Göbekli Tepe. Karahan Tepe and several other recently identified sites in the same region, including Taş Tepeler or Stone Hills, suggest that Göbekli Tepe was not an isolated phenomenon, but part of a much larger regional tradition of monumental construction. The area of southeastern Turkey and northern Syria appears to have been a centre of cultural activity and monument building that was far more extensive than previously known. The region where these sites are concentrated is the Northern Fertile Crescent, exactly the area where the Natufian culture was developing proto-agricultural practices in the period before the Younger Dryas. This is not a coincidence. The specific geography of the region, with its wild progenitors of domesticated wheat, barley and legumes, and its populations of wild sheep, goats, and cattle that would be domesticated, made it the natural cradle of agriculture once the Younger Dryas ended and population pressure resumed. The Natufian culture, which occupied the Levant from approximately 14,500 to 11,500 years ago, is particularly interesting for the rebuilt world question. The Natufians were the most complex hunter-gatherer culture ever known. They built permanent or semi-permanent villages. They had a complex symbolic and artistic tradition including carved figurines and elaborate burial practices. They stored and processed wild grain on a large scale. They had territory and property, as evidenced by specific storage facilities associated with specific structures. The Natufian culture was interrupted by the Younger Dryas. The evidence shows a clear reduction in settlement permanence, site size, and cultural complexity during the Younger Dryas cold and dry period in the Levant. When the Younger Dryas ended approximately 11,700 years ago, the Natufian tradition, or its successors, rapidly developed full agriculture and permanent settlement. The speed of this development after the Younger Dryas ended is remarkable, and suggests that the knowledge and infrastructure for agriculture was already substantially developed before the Younger Dryas disrupted it. This is the rebuilding. The Natufian culture, disrupted and reduced by the Younger Dryas, rebuilt rapidly after the catastrophe ended because it was drawing on a pre-existing knowledge base that had been maintained through the difficult period. What emerged as the Neolithic Revolution was not a new invention. It was the recovery of a capability that the Younger Dryas had interrupted. Now let us consider what the phrase rebuilt world most honestly and most carefully means. The world is rebuilt in the specific sense that the organizational complexity of human civilization was reduced to near zero by a series of catastrophic events at the end of the Pleistocene, and then gradually rebuilt over the following several thousand years by populations drawing on the surviving cultural memories and practical knowledge of what had existed before. The specific technologies of the Neolithic, agriculture, ceramics, polished stone tools, organized religion, long-distance trade, did not emerge from nowhere. They emerged from populations that retained cultural traditions reaching back into the Pleistocene, traditions that included knowledge of plant cultivation, animal management, astronomical observation, and the construction of large communal structures. The world is rebuilt in the physical sense that the specific geography of the human world changed dramatically. The coastal plains and continental shelves where the most populous and culturally rich Pleistocene communities lived are now underwater. The world we inhabit, with its coastlines and its cities, is a different physical world from the one that existed 12,000 years ago. We're not living on the same surface, we're living above it, on a world reshaped by 120 meters of sea level rise. The world is rebuilt in the biological sense that the ecosystems of the current world are the successors of ecosystems that were catastrophically reorganized at the end of the Pleistocene. The megafauna that shaped the grasslands and forests of the late Pleistocene are gone. The landscapes we regard as natural are landscapes that have been managed and modified by human activity for at least 10,000 years, in some cases much longer. The wildness we seek in the natural world is the wildness of a post-catastrophic landscape. not the wildness of a world at its ecological peak. And the world is rebuilt in the cultural sense that the civilizations we have built, with their cities and their writing and their religion and their science, are constructed on the foundations of older traditions whose depth we are only beginning to understand. When we look at the earlier Sumerian texts and find mathematical systems, astronomical records, and cosmological narratives of unexpected sophistication, we're looking not at the beginning of intellectual culture, but at the preserved remnant of an even older tradition that had survived the catastrophe in the memories and practices of the people who rebuilt. Let us go deeper into the specific archaeological evidence that is changing the picture of what the world looked like before the Younger Dryas. Because Göbekli Tepe, remarkable as it is not the only discovery that has been pushing the timeline of human sophistication further into the past. In 2021, archaeologists announced the discovery of a circle of wooden posts at the site of Warn Morn in Wales that predates Stonehenge by several hundred years, and that appears to have been dismantled and moved, with some of its stones ending up at Stonehenge. The specific stones can be matched to their original sockets at Warn Morn. This discovery is significant not primarily because it pushes the date of monument building further back, though it does, but because it reveals something about the specific cultural practices of the people involved. They dismantled a monument and moved its stones to a new location. This is not the behaviour of a society at the beginning of monumental construction. It is the behaviour of a society with a long tradition of monument building and a sophisticated understanding of the ritual significance of specific stones. In Indonesia, a cave painting at the site of Liang Bulu Sipong 4 in Sulawesi has been dated to at least 44,000 years ago, making it among the oldest known figurative art in the world. The painting depicts a hunting scene with human figures and animals, including therianthropes, part human, part animal figures that suggest complex mythological thinking. The existence of figurative art depicting mythology in Sulawesi 44,000 years ago means that the cognitive and cultural foundations of mythological thinking were present in humans who were not in contact with the European populations that produced the famous cave art of France and Spain. This geographic diversity of ancient sophisticated art is important. It means that complex symbolic and narrative thinking was not a local phenomenon that developed in one place and spread. It was a species-wide cognitive capability that manifested independently in multiple locations. The specific traditions varied, but the underlying capacity was universal. In South Africa, the Blombus cave site has produced evidence of symbolic behaviour, including ochre pieces with geometric engravings and shell beads used as personal ornaments dating to approximately 75 to 100,000 years ago. The Pinnacle Point site has produced evidence of shellfish exploitation and ochre use dating to approximately 164,000 years ago. These dates push the emergence of modern cognitive behaviour well before the Toba eruption and into a period that is genuinely ancient, even by the standards of modern humans. What all of these discoveries, from Blombos Cave to Göbekli Tepe to Warn Morn, are telling us is that the standard timeline of human cognitive and cultural development has been consistently too conservative. Every time archaeologists have established a date as the earliest evidence for a specific capability, subsequent discoveries have pushed that date further back. The pattern is so consistent that it is reasonable to treat the current earliest dates not as reliable minimums, but as artifacts of incomplete archaeological sampling. we have excavated a tiny fraction of the available archaeological record, in part because most of the relevant sites are either underwater or in regions that have not been systematically surveyed, and is part because the specific preservation conditions required to maintain organic materials through tens of thousands of years are relatively rare. What we have found is extraordinary. What we have not found is almost certainly more extraordinary still. The torrid meteor stream is a real astronomical feature that has been proposed as a possible source of periodic large-scale impacts on Earth. Understanding it provides context for both the Younger Dryas impact hypothesis and the broader question of how frequently civilizational scale catastrophes might occur. The torrid meteor stream is a broad swath of interplanetary debris distributed along a specific orbital path that Earth crosses twice per year, in late October to early November and in late June. The debris in the stream is the remnant of a large comet that fragmented sometime in the last 20,000 to 30,000 years. The stream includes not just fine dust that produces meteor showers, but also larger objects, some of which may be hundreds of meters in diameter. Bill Napier of Army Observatory in Northern Ireland has done significant work on the Torrid complex. His analysis suggests that the fragmentation of a large comet in the inner solar system within the past 20,000 to 30,000 years would have produced a debris cloud dense enough to cause periodic episodes of elevated impact risk over geological timescales. Specifically, the orbital mechanics of the torrid stream suggest that Earth encounters particularly dense regions of the stream at intervals of approximately 1,500 years, and that some of these encounters may have produced significant impact events in the geological and historical record. The connection to the Younger Dryas is direct. The Younger Dryas boundary event of approximately 12,900 years ago falls within the time frame during which the Torrid complex would have been at its most dangerous, when the progenitor comet was more recently fragmented and the debris was denser. Napier's models suggest that the specific impact event or airburst responsible for the YDB layer is consistent with what would be expected from the Torrid complex at that period. Beyond the Younger Dryas, the Torrid hypothesis has been proposed as an explanation for other significant events in the archaeological and historical record. The Bronze Age collapse, occurring approximately 3,200 years ago, may correspond to one of the periodic encounters with the dense region of the Torrid stream. The Late Bronze Age environmental records, including evidence for widespread fires and climate disruption during this period, are consistent with an elevated impact flux, though this interpretation remains speculative. The Torrid stream is still there. Earth still passes through it twice a year. The object tracking programs that monitor near-Earth asteroids have identified several large objects associated with the Torrid complex, including the asteroid 2015 TX-24. The question of what is still lurking in the stream, undetected, is taken seriously by planetary defense researchers. If the Torrid complex is indeed responsible for periodic catastrophic impact events, and if the cycle of approximately 3,000 to 4,000 years between the most dangerous encounters is approximately correct, then understanding this pattern is relevant to assessing when the next major encounter might occur. The mathematics are imprecise, and the hypothesis is not mainstream consensus. But the underlying observation that Earth is periodically at elevated impact risk due to the structure of the inner solar system's debris is not controversial. The question of ancient maps is one that alternative history enthusiasts raise often, and mainstream scholars dismiss quickly, but there are specific aspects of the subject that deserve more careful treatment. The Piri Reis map, drawn by an Ottoman admiral in 1513, is often cited as evidence of an advanced pre-Ice Age cartographic tradition, because it allegedly depicts Antarctica without its ice cover. This claim has been examined repeatedly and is not supported by careful analysis of the map. The landmass at the bottom of the Piri Reis map is most plausibly identified as a distorted rendering of the South American coastline rather than Antarctica. The admiral himself noted in his annotations that he drew on approximately 20 earlier maps, including maps made by the Portuguese from their explorations and earlier Arab and possibly ancient sources. The construction of a composite map from multiple partial sources would naturally produce distortions and misplacements. The claim that the map shows Antarctica is not supported by cartographic analysis and should be dismissed. However, the general question of ancient geographical knowledge deserves more careful treatment than either uncritical acceptance of alternative claims or blanket dismissal. The specific example of Strabo's geography, written approximately 2,000 years ago, shows that ancient geographers had a surprisingly sophisticated understanding of global geography, including knowledge that the world was spherical and reasonable estimates of its size. Eratosthenes, who lived approximately 300 years before Strabo, calculated the circumference of the Earth with remarkable accuracy using the observation of shadow angles at different latitudes. The specific question of whether ancient peoples had knowledge of continents or features that they had not directly explored through conventional maritime routes is one that is genuinely uncertain. The specific navigational capabilities of Polynesian peoples who colonized much of the Pacific Ocean, including islands as remote as Easter Island and Hawaii, using sophisticated star navigation, demonstrate that pre-modern navigators were capable of extraordinary feats of open ocean travel. Similar capabilities in other ancient maritime cultures cannot be assumed but also cannot be excluded. What is defensible is the observation that ancient geographical knowledge was more sophisticated and more extensive than we might naively assume, and that the specific sources available to compilers like Piri Reis may have included maps or geographical information whose origin is not fully understood. What is not defensible is the specific claim that the Piri Reis map shows ice-free Antarctica. The question of cultural memory transmission across the catastrophic boundary of the Younger Dryas is one of the most interesting and most difficult in the study of deep prehistory. How much of what was known by the most sophisticated pre-Younger Dryas populations survived the catastrophe? What specific knowledge was preserved, and how was it preserved, in a world without writing, through 1,200 years of severe cold and population reduction? The specific mechanism of oral tradition is the primary candidate. All pre-literate cultures transmit knowledge through oral tradition, and the capacity of oral tradition to preserve specific information with high fidelity over long periods has been underestimated by scholars accustomed to thinking of knowledge preservation as requiring writing. Research on oral tradition in Aboriginal Australian cultures has found that specific geographical knowledge, including the location of landmarks that were submerged by sea level rise more than 7,000 years ago, has been preserved in oral traditions with enough accuracy to correspond to known geological features. If oral traditions can preserve specific geographical information through more than 7,000 years of cultural change, including the changes brought by British colonisation and the disruption of traditional life, then oral traditions from populations that experienced the Younger Dryas catastrophe could in principle have preserved memories of that event and of the world that preceded it. The specific process of how knowledge is preserved in oral tradition is relevant to understanding what survived. Oral cultures that preserve knowledge tend to do so through formalized practices, narrative traditions, ritual recitation, ceremonial reenactment. Knowledge embedded in these formalized practices is more likely to be transmitted accurately because the formalization itself provides error correction. Deviations from the established form are noticed and corrected by the community of practitioners. The flood myths and Golden Age traditions that appear across world cultures may represent the surviving residue of exactly this kind of formalized oral preservation. The specific theological and narrative frameworks in which these traditions are embedded vary by culture and have been elaborated over the millennia since the original experiences, but the core structural elements, a world before, a catastrophe, a survivor, a rebuilding, may represent the fossil of an original account that was systematically preserved because it was embedded in ritual and formalized tradition. This is speculative. We cannot prove that specific flood myths encode memories of the Younger Dryas or of the coastal flooding of the Pleistocene world, but the consistency of the structural pattern across independent traditions and the correspondence of the timescale that the myths point to with the actual geological events makes this interpretation at least as plausible as the alternative explanation that dozens of independent cultures independently invented identical narrative structures with no common experiential root. Let us consider one more specific dimension of the rebuilt world question that is often overlooked in both the mainstream and the alternative history treatments of this subject. The question of what rebuilding actually requires and what it tells us about the nature of the civilizational project. Every civilization that has been built by specific people, in specific places, responding to specific circumstances, drawing on specific inherited knowledge and practices. The civilizations of the Neolithic were built by people who had survived the Younger Dryas, who remembered or inherited memories of what has been lost, and who were applying their accumulated knowledge to the specific circumstances of the early Holocene. The specific form that the rebuilding took, agriculture rather than sophisticated monument building, cities rather than dispersed seasonal camps, writing rather than oral tradition, reflects the specific circumstances of the early Holocene rather than simply the continuation of Pleistocene practices. Agriculture emerged not because it was obviously superior to hunting and gathering, but because the specific resource conditions of the early Holocene, with the megafauna gone and the wild plant and animal populations reorganizing after the Younger Dryas, made it a viable strategy in a way it had not been before. This specific ecological context for the emergence of agriculture is important for the rebuilt world hypothesis, because it helps explain the timing. Why did agriculture emerge approximately 10,000 years ago, rather than earlier? The answer suggested by the rebuilt world hypothesis is that the organizational impulse and knowledge base for agriculture were present earlier, as suggested by the Natufian evidence, but the specific ecological conditions that made it viable and necessary were created by the Younger Dryas catastrophe. The catastrophe that disrupted the pre-existing sophisticated cultures also created the conditions for a different kind of sophistication to emerge from the rebuilding. This is a genuinely different interpretation from both the standard narrative and the alternative history narrative. The standard narrative says agriculture was a new development that emerged naturally from the growing cognitive capacity of Homo sapiens. The alternative history narrative says there was a lost advanced civilization that may have had agriculture already. The rebuilt world interpretation says that the knowledge base for agriculture existed in the Pleistocene cultural tradition and was applied to the specific post-Younger Dryas ecological circumstances by the survivors, producing the specific historical form of the Neolithic revolution that we can observe in the archaeological record. This interpretation is consistent with all the known evidence. It does not require hypothesizing about lost continents or suppressed discoveries. It requires only that we take seriously the possibility that the late Pleistocene populations were culturally and intellectually more sophisticated than the standard narrative has assumed, and that the specific trajectory of the Neolithic revolution reflects the interaction between pre-existing knowledge and the specific post-catastrophe ecological circumstances in which it was applied. There is a philosophical dimension to the rebuilt world question that belongs in this discussion, because it affects how we think about our own moment in the story. The civilization we've built is, in a specific sense, the most capable in the human story. We have achieved things no previous civilization achieved: global communication, the mapping of the genome, the understanding of the structure of the cosmos from the smallest subatomic particle to the largest gravitational structure. We have eliminated diseases that killed millions throughout history. We have produced, in less than a century, a scientific understanding of the natural world that is broader and deeper than everything that came before it combined. And yet the rebuilt world framework asks us to hold this achievement with a specific humility. Not the humility of false modesty, but the humility of accurate temporal perspective. The world we have built has been built in a very short time, by people who are drawing on accumulated knowledge going back millions of years of human evolutionary development, and who were, in the context of the full human story, the beneficiaries of everything that every previous generation of humans built and lost and partially preserved through the catastrophes they survived. The specific knowledge that has made modern science possible, the mathematics, the logic, the experimental method, these have long ancestral lines that reach back through the Greek and Islamic and Indian and Chinese mathematical traditions, which reach back to Babylon and Egypt, which reach back to the accounting practices of the first cities, which reach back to the counting and measuring traditions of the late Paleolithic. The line from a 45,000-year-old bone with tally marks to the mathematics of quantum mechanics is continuous. We did not build the world from scratch. We rebuilt it from the ruins of everything that came before, and the specific capabilities we have built it with were transmitted to us through a chain of human minds, stretching back to the beginning of our species and possibly beyond. Every human who learned to count, who noticed a pattern in the sky, who kept a record of something important, who taught their children what they had learned, is part of the ancestry of the world we inhabit. The rebuilt world is the human project. It is what we do. We build worlds. When the worlds collapse, we save what we can and we build again. The building is the story. The catastrophes are the punctuation. There are specific sites around the world whose existence or whose specific characteristics present genuine puzzles for the standard archaeological narrative. Puzzles that deserve honest examination rather than either enthusiastic overclaiming or reflexive dismissal. Pumapunku, at the site of Tiwanaku near Lake Titicaca in Bolivia, is a genuine archaeological puzzle. The site contains large blocks of andesite and red sandstone that have been shaped with extraordinary precision. The andesite blocks were quarried from a source approximately 90 kilometers from the site and transported to their current location, presumably by a combination of water transport across Lake Titicaca and overland movement. The precision of the stonework at Pumapunku is remarkable. Some of the surfaces are flat to within a fraction of a millimetre over a length of several metres. Interlocking components fit together with tolerances that would be impressive in a modern machine shop. The specific puzzle of Pumapunku is not that it could not have been made by the Tiwanaku culture, which was clearly a sophisticated civilization that built other extraordinary structures at the site. The Tiwanaku culture was capable of remarkable things, and the mainstream archaeological explanation that this is the work of skilled craftsmen using abrasive stone tools is not impossible. The puzzle is the extraordinary precision of the stonework relative to the tools that were available. Achieving the specific surface tolerances visible at Pumapunku with stone tools and abrasives would require an extraordinary investment of time and skill. The question of how specifically they achieved this precision with the technology available is genuinely unanswered. The pyramids of Bosnia, specifically the Bosnian Pyramid of the Sun near the town of Visoko, represent a different kind of puzzle. Since their discovery in 2005 by Samir Osmanagic, they have been enthusiastically promoted as the world's largest man-made pyramids. The mainstream archaeological consensus is that these are natural geological formations, the specific angular appearance being the result of fluvio-glacial erosion processes that produced pyramidal topography. The evidence cited for their natural origin includes the geological stratigraphy, showing natural sediment deposition and the absence of credible dating evidence for the alleged construction. I am noting the Bosnian pyramids specifically as an example of how not to approach the rebuilt world question. The evidence for natural origin in this case is strong, and the claims of artificial construction are not supported by rigorous archaeological investigation. Enthusiasm for the rebuilt world hypothesis does not require accepting every claimed anomaly without critical evaluation. The Bosnian pyramids are almost certainly not pyramids in the archaeological sense, and accepting the overclaimed version of this site damages the credibility of legitimate anomalies that deserve serious investigation. The honest approach to the rebuilt world question requires exactly this kind of discrimination, engaging seriously with genuine anomalies like Göbekli Tepe, the Antikythera mechanism, and the Younger Dryas impact evidence, while being skeptical of overclaimed or poorly documented cases that do not withstand critical scrutiny. Sacsayhuaman in Peru is a more legitimate case for careful examination. The Inca fortress complex above Cusco contains massive stone walls built from enormous polygonal blocks fitted together without mortar with extraordinary precision. Some blocks weigh hundreds of tons. The specific fitting of the polygonal blocks, with their irregular, many-sided shapes fitting together like a three-dimensional jigsaw puzzle with millimetre tolerances, is accomplished without any gaps large enough to insert a knife blade. The Inca civilization clearly built Sacsayhuaman. The historical documentation is clear. The specific methodology used to achieve the precise fitting of enormous irregular polygonal blocks is less clear. Various proposals have been made, including the use of a process of progressive refinement in which blocks are fitted against each other repeatedly, and the high points ground down until a perfect fit is achieved. This method would produce exactly the kind of precision visible at Sacsayhuaman, but would require an extraordinary investment of time and skilled labour. The specific question of how the Inca moved and placed multi-hundred-ton blocks is also genuinely uncertain. Experimental archaeology has demonstrated that large stones can be moved by large numbers of people, using ropes, rollers and levers, and this is the most parsimonious explanation. But the specific engineering challenges of the largest blocks at Sacsayhuaman and at other Andean sites like Ollantaytambo and Tiahuanaco are not fully resolved. What these South American sites tell us is that ancient builders were capable of achieving results that we find surprising given our assumptions about their technological level. This is consistent with the broader rebuilt world framework. The human capacity for sophisticated technical achievement is not a recent development, and the specific achievements of ancient peoples should not be automatically dismissed as impossible, simply because we do not immediately understand how they were accomplished. The concept of cultural memory and how it operates across long time scales is relevant to understanding how specific knowledge might survive for thousands of years in pre-literate societies. Research by Patrick Nunn and Nicholas Reed, published in 2016 in the journal Australian Geographer, examined indigenous oral traditions from Aboriginal Australian communities and compared them to the geological record of sea level rise along the Australian coast. They found that specific oral traditions describing the flooding of coastal areas by the sea, traditions describing specific geographical features that no longer exist above sea level, corresponded accurately to geological evidence for sea level changes that occurred between 7,000 and 10,000 years ago. The traditions they examined described specific events, islands that are now submerged but that appear in traditional stories, waterways that are now dry land, coastal areas that are now deep water but that appear in stories as fishing grounds or camping places. The geological record confirmed the specific geographical features that the traditions described. The oral traditions had preserved accurate geographical information through 7,000 years of cultural continuity. Information about the specific landscape of a world that had been inundated when the last traces of the Ice Age sea level rose. This research provides direct empirical evidence for the capacity of oral tradition to preserve specific geographical information with high fidelity over timescales of thousands of years. It is not speculation. It is documented, independently verifiable correspondence between oral tradition and the geological record. The implication for the rebuilt world question is significant. If Aboriginal Australian oral traditions have preserved accurate geographical information for 7,000 years, it is not implausible that oral traditions across multiple cultures could have preserved memories of events from 12,000 years ago. The flood myths of the world may not be independent mythological inventions. They may be the surviving echoes of specific cultural memories preserved for 12,000 years through exactly the kind of oral tradition that the Australian research documents. The specific cultural mechanisms that allow oral traditions to preserve information with high fidelity over thousands of years are worth understanding. They include the embedding of information in formalized narrative structures that allow errors to be detected and corrected by community members who know the tradition. They include the embedding of information in ritual and ceremony, which provides a regular rehearsal that maintains the tradition in active use. They include the social structures that support specialist practitioners of tradition, people whose specific social role is to maintain the accuracy of the transmitted knowledge. These mechanisms were not unique to Aboriginal Australian culture. They were present in all pre-literate cultures. The specific oral traditions of the ancient Near East, including the Sumerian and Akkadian traditions that eventually produced the written texts that survive to us, were maintained for thousands of years before writing existed. What those texts contain when they first appear in written form is not the beginning of a tradition, but the transcription of a tradition that was already ancient. The Epic of Gilgamesh, the oldest substantial work of literature in the world, begins with the declaration that its protagonist Gilgamesh himself set down his experiences in writing on a lapis lazuli tablet that he deposited in the foundations of the city wall of Uruk. This literary conceit, the author as his own historian, suggests that the tradition being transcribed understood itself as recording a very old story. The specific flood narrative in the Epic of Gilgamesh, the story of Utnapishtim who survived a divine flood by building a boat, is embedded in a larger narrative about wisdom and the search for immortality that has all the characteristics of a story that has been told and retold for many generations. The antiquity of the Gilgamesh tradition, the depth to which it reaches before it was written down, is not known, but the evidence from comparative mythology suggests that the flood narrative was already old when it was incorporated into the Gilgamesh cycle. Parallel flood traditions in the Atrahasis epic and the Sumerian flood story represent independent versions of the same underlying tradition, suggesting the tradition predates the specific literary forms in which it has survived. There is a question that the rebuilt world hypothesis raises that goes beyond the specific archaeological and geological evidence. It is a question about the nature of knowledge itself and about what a civilization actually is. We tend to think of civilization as a collection of specific technologies: writing, agriculture, metallurgy, urban planning. These are the markers that archaeologists use to identify civilization in the archaeological record. A site with evidence of agriculture and writing and urban planning is a civilization. A site without these markers is pre-civilization. But this definition conflates the tools of civilization with civilization itself. The tools are expressions of specific capabilities. The capabilities are expressions of specific forms of knowledge, and the knowledge is held by specific people operating within specific social contexts. What a civilization actually is, at root, is a set of people with shared knowledge, organized in ways that allow that knowledge to be applied to collective problems and transmitted to subsequent generations. Under this definition, the question of when civilization begins and ends is more complex than the toolkit approach suggests. A community with sophisticated astronomical knowledge, complex social organization, the capacity for large-scale cooperative labor, and an active tradition of cultural transmission is civilized in the meaningful sense even if it does not yet have writing or metallurgy. And a community that has lost most of its members to catastrophe, that has retreated to subsistent survival in marginal environments, may still be civilized in the sense that its surviving members carry the knowledge and the cultural traditions of a more sophisticated predecessor. The rebuilt world hypothesis suggests that the late Pleistocene world contained communities that were civilized in this meaningful sense, that the Younger Dryas and the sea level rise and the associated catastrophes reduced those communities to their minimal viable cores, and that the Neolithic and Bronze Age civilizations represent the rebuilding from those cores using the surviving knowledge base of what had come before. This is a different way of thinking about the timeline of civilization. Instead of a single line from primitive to advanced, it suggests a pattern of builds and collapses, of sophistication achieved and then reduced and then rebuilt. with each rebuilding drawing on what survived from the previous peak. The specific form of each rebuilt civilization depends on two things: what knowledge survived the collapse, and what specific ecological and social circumstances the survivors faced in rebuilding. The specific form of the Neolithic Revolution, with its particular combination of grain agriculture, pottery, polished stone tools, and the specific animals that were domesticated, reflects the specific knowledge and the specific ecology of the early Holocene Fertile Crescent. A different set of survivors in a different environment, with a different knowledge base, would have built something different. This framework is not just historically interesting, it is relevant to understanding what is most important to preserve in our own civilization. The rebuilt world hypothesis suggests that the most robust and most valuable knowledge is knowledge embedded in durable forms, in practices that can be maintained by small groups, in traditions that are actively rehearsed and transmitted, in physical structures that can survive for thousands of years. The most vulnerable knowledge is knowledge that depends on complex infrastructure, the specific technical knowledge of advanced manufacturing, of digital information systems, of complex supply chains. These forms of knowledge, like the linear B script of the Mycenaean palace administrators, can disappear within a single generation if the systems they depend on are disrupted. The question of what we're doing to preserve our most important knowledge against the possibility of catastrophic disruption is one that the rebuilt world framework makes urgent. Previous civilizations did not have the luxury of knowing what had happened before them in the way that we do. We know about the Younger Dryas, we know about the Bronze Age collapse, we know about the pattern of civilizational disruption. We have the rebuilt world framework, however partial and uncertain, as a guide to what is worth preserving and how to preserve it. That is the specific gift that the study of the rebuilt world offers us. Not nostalgia for lost golden ages, not fear of inevitable catastrophe, but the specific, practical, actionable awareness that the things most worth preserving are the things most worth embedding in the most durable forms available, in practices and traditions and physical structures that can survive the kinds of disruption that have, repeatedly, ended the worlds that came before ours. The submerged landscapes of the world deserve more attention than they typically receive in discussions of ancient history. We have mentioned the raw numbers: 27 million square kilometers of drowned land. But let us make those numbers concrete by looking at specific places. The Persian Gulf was not a sea 12,000 years ago. It was a river valley. The Tigris and Euphrates, the Karun from Iran, and the Wadi Batin from Arabia converged in the center of what is now the Gulf, and flowed as a single major river southward through a narrow strait into the Indian Ocean. The valley they created was exceptionally fertile. Flanked by the highlands of Arabia and Iran, watered by several major rivers, sitting in a region with a productive climate during the terminal Pleistocene, this valley would have been one of the most attractive environments for human settlement, available anywhere in the late Pleistocene world. Geologist Jeffrey Rose of the Max Planck Institute for Evolutionary Anthropology has proposed that this Gulf oasis, as he calls it, was a major centre of human population during the late Pleistocene. His hypothesis is supported by the archaeological evidence from the surrounding regions, which shows anomalously high concentrations of sophisticated Paleolithic tools in areas adjacent to what would have been the shoreline of the oasis during its habitable period. The specific tool assemblages suggest cultural connections between widely separated modern populations that are difficult to explain without invoking a common geographical origin that is now underwater. If the Gulf Oasis hypothesis is correct, a large and culturally sophisticated population occupied what is now the Persian Gulf for tens of thousands of years before the sea level rise of the early Holocene flooded the valley between approximately 8,000 and 6,000 years ago. The Sumerian civilization, which emerged in southern Mesopotamia beginning approximately 6,000 years ago, would have been the successor to this flooded culture, inheriting its cultural traditions and applying them to the changed post-flood geography of the Delta region. The specific timing is suggestive. The Sumerian king lists antediluvian kings with their impossibly long reigns are sometimes interpreted as encoding a memory of a very long period of pre-Sumerian occupation of the region, a period that preceded the flood that ended that occupation. If the flood in question is the flooding of the Persian Gulf rather than a global flood, the king list may be preserving a specific geographical memory of a specific regional catastrophe. This interpretation is speculative, but it illustrates the kind of specific, geographically grounded hypothesis that the rebuilt world framework generates. Not vague claims about lost civilizations, but specific proposals about specific flooded landscapes and their relationships to specific cultural traditions. Similarly, the North Sea shelf, known as Doggerland, was inhabited by Mesolithic people until approximately 8,000 years ago when the rising North Sea finally covered it completely. The transition from dry land to sea was not instantaneous. It happened over thousands of years, with periodic rapid flooding events as glacial meltwater lakes drained and sea levels rose in pulses. The specific experience of generations of people watching the sea progressively claim the land they had known, watching the rivers become estuaries and then bays and then open sea, would have been a living catastrophe for those populations. The memory of this process may be preserved in the specific flood traditions of Northern Europe, including the Norse mythology of the world surrounded by ocean. The specific Norse cosmological tradition of Yggdrasil, the world tree, with its roots connecting different realms, including the realm of the dead beneath the earth, may encode memories of a world where what was known land has become the realm beneath the sea. The Black Sea provides another specific case. At the end of the last ice age, the Black Sea was a freshwater lake, isolated from the Mediterranean by a land bridge across what is now the Bosphorus Strait. The Mediterranean sea level was rising. At some point, approximately 7,600 years ago, the rising Mediterranean waters overtopped and then catastrophically breached the land bridge. The resulting inrush of salt water raised Black Sea levels by perhaps 30 to 60 meters and flooded an estimated 100,000 square kilometers of previously habitable land. This specific event, the Black Sea flood hypothesis proposed by geologists William Ryan and Walter Pittman in 1997, has been proposed as the specific historical event behind the Babylonian and biblical flood myths. The hypothesis has been subsequently refined and debated, with some evidence supporting and some complicating the specific scenario. But the basic geological event is not in dispute. The Black Sea did transition from a freshwater lake to a salt sea connected to the Mediterranean, and this transition did involve the flooding of previously inhabited land. The specific point for the rebuilt world question is not whether the Black Sea flood was the origin of specific myths. It is that the rise in sea levels at the end of the last ice age produced multiple specific catastrophic flooding events in different regions, events that were experienced by specific populations of people who would have preserved the memory of those events in their cultural traditions. The flood myths are not a single event multiply told. They may be the accumulated memories of multiple specific floods, each experienced by specific populations, each preserved in specific cultural traditions, and all sharing the common structure of catastrophic water that changed the world. The question of what specifically was preserved through the Younger Dryas and the early Holocene flooding events, and how it was preserved, connects to a deeper question about the nature of knowledge and what kinds of knowledge are most robust in the face of civilizational catastrophe. Not all knowledge is equally fragile. Some knowledge is embedded in physical objects that can survive for thousands of years. Stone tools, carved pillars, painted walls, these can survive. Some knowledge is embedded in practices that can be maintained by small populations. Basic agricultural techniques, fire making, the construction of simple tools, these can be maintained by a handful of people and reconstructed by their descendants. Some knowledge is extremely fragile. Writing, complex astronomical calculations, sophisticated medical techniques. These require specialists operating within a functioning complex society and can be lost within a single generation if the society that supports the specialists collapses. The specific knowledge that survived the Younger Dryas was therefore not uniform. It was the residue of a complex filter. The knowledge that passed through was primarily the knowledge embedded in durable cultural forms, in oral tradition, in persistent practices, and in the symbolic traditions that were embedded in ritual and religious life. The knowledge that was lost was primarily the specialized technical knowledge that depended on the organizational infrastructure of complex society. This is why the cultural traditions that emerge after the Younger Dryas, the Neolithic cultures of the early Holocene, show both deep cultural continuity with what came before in their astronomical knowledge and their symbolic traditions and their monument building, and discontinuity in their specific technical capabilities. The knowledge of how to build a large astronomical monument survived the catastrophe because it was embedded in ritual tradition and transmitted through ceremony. The specific knowledge of more complex technical processes, whatever those may have been, was not similarly embedded and was therefore not similarly robust. The specific form in which astronomical knowledge survived through the Younger Dryas is particularly interesting. Astronomy requires patience and precision and record keeping. But it does not require complex physical infrastructure. A person can observe the sky with nothing more than their own eyes and a knowledge of what to look for. The patterns of the stars, the cycles of the sun and moon, the precession of the equinoxes, these are all in principle recoverable from pure observation over generations. The persistence of sophisticated astronomical knowledge across the Younger Dryas may be explained by exactly this robustness of observational astronomy. Populations reduced to a few thousand people, living in marginal environments during 1200 years of cold, could still observe the sky. They could still note the position of the stars and the sun. They could still maintain the oral tradition that recorded what the previous generations had observed. The specific astronomical knowledge that shows up in the monuments and texts of the early civilizations may be the accumulated knowledge of generations of sky watchers who maintained their tradition through the catastrophe. This has a practical implication. The specific astronomical alignments of the earliest monuments, including Göbekli Tepe and Nabta Playa and Stonehenge, may not represent the beginning of astronomical knowledge. they may represent the first physical expression of a knowledge tradition that is substantially older, a tradition that was maintained orally through the Younger Dryas and first given physical form in the monuments of the early Holocene. There is one more thread that must be followed before we can conclude our exploration of the rebuilt world question, the thread that connects the specific archaeological and geological evidence to the question of how we understand our own moment in the human story. We are living in a period of extraordinary scientific discovery. The specific tools available to archaeologists and geologists and geneticists today, radiocarbon dating refined by dendrochronology calibration, ancient DNA analysis, satellite archaeology revealing buried structures, underwater archaeology recovering submerged sites, isotopic analysis of ancient samples. These were not available a generation ago. Every year, new discoveries are pushing the boundaries of what we know about the ancient world. The pace of discovery is accelerating rather than slowing. The ancient DNA revolution, which began in earnest in the 2000s when technological improvements made it possible to sequence ancient genomes from degraded bone samples, is still producing fundamental revisions of our understanding of prehistoric population movements and cultural connections. The Denisovans, an entire archaic human lineage previously unknown to science, were discovered entirely through ancient DNA in 2010. We still have only a handful of their physical remains, but we have their genome, which shows up in the DNA of modern people across a vast area of Asia and the Pacific. This is a major human lineage that was completely invisible to archaeology until genetic technology made it visible. Similar revisions are underway in Paleolithic archaeology. The application of new dating techniques to cave art has repeatedly pushed dates back further than expected. Art that was thought to be aurigation, made by the first modern humans in Europe, has been found at some sites to predate the aurigation, raising questions about whether some European cave art was made by Neanderthals. The discovery at the site of La Pasiega in Spain of red pigment decorations on cave walls that date to 65,000 years ago, before modern humans arrived in Europe, raises the specific question of whether Neanderthals, not just Homo sapiens, were engaged in symbolic activity. The specific implication for the rebuilt world question is that the world is consistently proving to be more complex, more ancient, and more sophisticated than we thought. Every revision of the standard narrative in the past 30 years has been in the direction of greater complexity and greater antiquity. The timeline of human sophistication has been pushed back at every point where new data has become available. This does not mean the most extreme alternative history claims are supported. It does mean that intellectual humility about what the next generation of discoveries might reveal is warranted. The world that existed before the Younger Dryas was almost certainly more complex than we currently know. The specific nature of that complexity is something we're only beginning to understand. The rebuilt world hypothesis is ultimately a hypothesis about the scope of what we do not know, as much as it is a hypothesis about the specific nature of what once existed. It is a call for scientific humility, for continued investigation, and for the willingness to follow the evidence wherever it leads, even when it leads to conclusions that are uncomfortable for the standard narrative. The world we inhabit is layered. Below the cities are the ruins of older cities. Below the ruins are the soils of abandoned fields. Below the soils are the traces of the earlier settlements. Below the settlements are the tools of hunters who lived before agriculture. And below the surface of the sea that borders every continent are the drowned landscapes where the most populous and most sophisticated pre-agricultural populations lived. We are not at the beginning. We are not at the end. We are somewhere in the middle of a story that is much longer and much more complicated than any of the narratives we currently use to describe it. That is both humbling and exhilarating, and it is, in the most honest sense, what the evidence is telling us. Let us sit with one more specific thread before we come to the synthesis. The thread of what the world of 12,000 years ago actually looked like from the perspective of its inhabitants, and what the ending of that world would have felt like to the people who lived through it. The populations of the late Pleistocene were not simple people. They were anatomically and cognitively identical to us. They had language, complex social structures, symbolic thought, and the full range of human emotional and intellectual life. The painters of Chauvet Cave, looking up at the same cave ceiling that modern visitors see, were not primitive. They were people with a full human capacity for wonder, for memory, for grief, for love. When the Younger Dryas began, these people experienced the catastrophe as we would experience a catastrophe. They watched the climate change. They watched the prey animals decline. They watched the places they knew become uninhabitable. They moved, they adapted, they died in large numbers, and the survivors carried forward what they could: the stories, the knowledge, the traditions, the memories of a world that was being taken from them. The specific emotional texture of that experience is preserved in distorted form, in the mythological traditions that survive. The Golden Age traditions are not simply nostalgia, they are grief. The memories of a world before the flood are not simply narrative, they are testimony. The people who created these traditions were describing something that had been lost, something that had been real and was gone, and they were insisting that it be remembered. We are the inheritors of that insistence. The myth survived, the knowledge survived, the genetic lineages survived, and we are in the extraordinary position of having the scientific tools to read the evidence of what happened, to reconstruct in broad outline the catastrophe that ended the world that came before ours, and to understand, for the first time in human history, the deep context of the story we are living in. That understanding is not complete. It will never be complete. Too much was lost. But what we have is more than our grandparents had, and what our grandchildren will have will be more than we have. The picture is becoming clearer. The rebuilt world is becoming readable, and what it is telling us as we learn to read it is that we are not the beginning of the story. We are somewhere in the middle, building, as humans have always built, on the foundations of everything that came before. The specific practical question that the rebuilt world framework raises, the question of knowledge preservation in the face of potential catastrophe, is worth examining in more detail because it connects the deep past directly to the immediate present. Every civilization that has faced catastrophic disruption has lost knowledge in proportion to how specialized that knowledge was and how little redundancy existed in its preservation. The most specialized knowledge, the most fragile, the knowledge embedded in the most distributed and resilient forms, the most durable. We are in a specific position in history where the knowledge base of our civilization is simultaneously more comprehensive and more fragile than at any previous point. More comprehensive because the accumulated scientific and technological knowledge of the modern world exceeds anything that any previous civilization possessed. More fragile because a larger proportion of that knowledge is stored in digital forms that depend on continuous power supply and on the functioning of extremely complex information infrastructure. The Library of Alexandria, in ancient times the great repository of classical knowledge, was destroyed in stages over several centuries. The loss of its contents is correctly remembered as a tragedy. But the knowledge stored at Alexandria existed in physical form, in manuscripts that could be read by anyone with the relevant literacy, and much of what was stored there was duplicated at other sites across the Mediterranean world and beyond. The Islamic Golden Age preserved and built upon much of the classical knowledge that survived Alexandria's destruction, precisely because that knowledge existed in multiple physical copies distributed across a wide geographic area. The specific knowledge held in digital form in the modern world does not have the same redundancy. The specific software systems, the specific databases, the specific digital archives that contain much of the accumulated knowledge of the modern world exist in forms that require functioning power infrastructure and functioning digital hardware to access. They are backed up, but the backups also require power and hardware to access. In a world where power infrastructure was severely disrupted, the accessibility of digitally stored knowledge would be dramatically reduced. This is not an argument against digital knowledge storage. It is an observation that the transition to digital storage has created a specific vulnerability that previous knowledge storage methods did not have. The ancient practice of carving important information into stone, famously durable if inconvenient, has been replaced by a practice of storing information in forms that are convenient but specifically vulnerable to the kinds of disruption that the rebuilt world framework tells us have happened before. The specific most important knowledge to preserve against catastrophic disruption is the knowledge most likely to be needed in rebuilding: basic science, basic mathematics, agricultural techniques, medical knowledge, engineering principles. Much of this knowledge is currently preserved in physical form in libraries and in the minds of trained practitioners. But the ratio of digital to physical preservation has been shifting rapidly in the direction of digital, and the long-term resilience implications of this shift deserve more attention than they currently receive. The rebuilt world framework is ultimately an argument for taking the long view, for thinking about civilization not as a linear progression from a primitive past to an advanced future, but as a cyclical and vulnerable project that has been periodically interrupted and rebuilt throughout the entire history of our species, for taking seriously the specific lessons that the history of those interruptions and rebuildings offers, and for making choices about what we preserve and how we preserve it with a full awareness of what has been lost in previous cycles. The world we inhabit was rebuilt. The worlds before ours were real, and they were rich, and they were lost. What we have inherited from them is fragmentary and partial, and encoded in forms that are difficult to read. The myths, the ruins, the genes, the alignments of ancient stones. We are reading those messages, slowly and imperfectly, and with instruments that get better every decade. And what they are telling us, cumulatively and with increasing clarity, is that the story is longer and more complex and more dramatic than any of the frameworks we have used to tell it. The rebuilt world is our world. The rebuilding continues, and the awareness of what came before is perhaps the most important thing the previous worlds left us. We need to be honest about the limits of this framework. The rebuilt world hypothesis, even in its most defensible form, is working at the edges of what the evidence firmly supports. The evidence for a sophisticated late Pleistocene cultural world is real but limited. The evidence for the Younger Dryas impact is growing, but not yet mainstream consensus. The evidence for specific cultural continuity from pre-Younger Dryas populations to post-Younger Dryas civilizations is inferential rather than directly documented. The alternative possibility that the standard narrative is approximately correct, and that the sophistication of Göbekli Tepe represents the beginning of a genuine new development rather than the survival of an older tradition, cannot be dismissed. The evidence for a pre-catastrophe world more sophisticated than we had assumed is suggestive, not conclusive. The connection between specific ancient myths and specific geological events is suggestive, not proven. The Schoch hypothesis about the Sphinx remains unconfirmed. What the rebuilt world framework offers is not a proven alternative history, but a set of questions that the standard narrative has difficulty answering and that deserve serious scientific investigation. Why is Göbekli Tepe there, at the time it is, built by people who should not yet have had the organizational capacity to build it? Why do flood myths appear in every human culture with such structural consistency? Why does the Younger Dryas boundary layer show impact markers at dozens of sites on multiple continents? Why is human genetic diversity so low relative to our geographic spread? Why does the Sphinx show weathering patterns that some geologists interpret as inconsistent with its assumed age? These are not answered by saying people are clever, and sometimes things that look mysterious have mundane explanations. That is true as far as it goes, but it does not constitute an explanation of specific anomalies. It is a placeholder for explanations that have not yet been provided. The most important implication of the rebuilt world framework is not archaeological or historical. It is about our relationship to our own situation. If the world we inhabit is in some sense a rebuilt world, if the civilization we're building is not the first but the latest in a series of human civilizational projects, if the catastrophes that ended previous worlds have real analogues in the physical and astronomical environment of today, then the question of what happens to our world becomes more urgent and more personal. We've explored in previous videos the specific risks that face modern civilization: severe space weather, geomagnetic catastrophe, the legacy of previous civilizational collapses. The rebuilt world framework adds to these a longer perspective. The world has been rebuilt before. The specific triggers of previous rebuildings, cosmic impacts, rapid climate change, sea level rise, ecosystem collapse, remain operative. The sun still erupts. The comets still orbit. The climate still changes. What the rebuilt world framework suggests is not fatalism. The survivors of every previous catastrophe rebuilt. The rebuilding was real. The current world, whatever its vulnerabilities, represents an extraordinary accumulation of knowledge and organizational capability that exceeds anything that existed in previous worlds. The specific knowledge that we have accumulated about the risks we face, knowledge that previous civilizations did not have, is itself a form of resilience that no previous world possessed. We know about the Younger Dryas impact. Previous people experienced it without understanding it. We know about the Carrington event. Previous people experienced it without conceptualizing it. We know about the dynamics of civilizational collapse. Previous people lived through those collapses without a framework for understanding the patterns that produced them. This knowledge is not a guarantee. The rebuilt world framework is not a prophecy of doom. It is an invitation to take seriously the full depth of the human story, including the chapters that ended in catastrophe, and to use that understanding to navigate the world we have inherited with more wisdom than the worlds before ours could manage. The shore at the edge of the sea at low tide, exposed rocks and sand that an hour ago were underwater and that an hour from now will be underwater again. This sea coming and going, the world changing below the surface of what we think we know. 12,000 years ago, under the water that covers the continental shelves, there were plains and rivers and beaches. People lived there. They built things we will never find. They knew things we will never recover. They looked up at the same stars we look at, and they told stories about what they saw. And some of those stories survived the flood that took their world, encoded in the myths of their descendants, and made it to us. We are those descendants. We are the latest chapter of the oldest story. The story of a species that builds worlds and loses them and builds again, carrying forward through each catastrophe whatever it can save of what came before. The world we inhabit is rebuilt, not in the sense that everything was lost and nothing survived, in the sense that what we have was constructed carefully and over millennia by people who were trying to recover what had been taken from them. The mathematics and the astronomy and the architecture and the mythology, they are the rescued cargo of a vessel that went down in the Younger Dryas, preserved by the survivors who swam to shore and refused to let go of what they carried. We stand on their shoulders, we live in their rebuilt world, and we are adding to it every day, not knowing whether the next flood is coming or when, but building anyway, because that is what humans do. Let all of this settle around you quietly tonight. The sea rising, the ice melting, the sky 11,000 years ago, blazing with something that ended one world and allowed the next to begin. The survivors gathering what they could carry and setting off across the changed landscape to find whatever new beginning was available to them. They found it. They built Göbekli Tepe on the hill above the flood. They domesticated the wild grains. They built cities on the plains of Mesopotamia. They raised pyramids on the desert plateau. They looked at the stars and measured their cycles and passed that knowledge forward, generation by generation, until it reached us. We are the inheritors. Everything we have was saved by someone who survived something we can barely imagine. The story we are living in is older and longer and more dramatic than any history book contains. You are part of that story, the latest chapter in the longest book ever written. Sleep well.